Good morning to everybody. Today I'll explain to you a very complex topic in a simple way. As you saw in the trailer, the topics of today are the general relativity of Einstein and the black holes. Einstein discovered that it's physically impossible to go beyond the light speed. The whole general relativity and the modern astrophysics are based on this discovery. For example, if I'm on a train and I throw a bottle from the window, the speed of the bottle with reference to an observant on the floor will be the speed of the train plus the speed of the bottle. But this doesn't happen with a light ray, because the speed of the light from the train with reference to the floor will always remain the same. But let's speak now about the first famous example of Albert Einstein. Let's imagine a man in a cabin with no possibility to see outside. The cabin is free-falling in a gravitational field. What happens if a man lets his cell phone fall in the air beside himself? The cell phone continues falling and there will be no relative movement between them. In practice, the man will think he is in an ideal inertial system. Albert Einstein brings another example. Let's imagine a man in a spaceship in an ideal inertial system with no possibility to see outside. The spaceship is moving with an acceleration of 9.8 meters per second. What happens if the man again lets his cell phone fall in the air beside himself? The cell phone continues its movement, but the floor of the spaceship will reach it due to its acceleration. The man will see the cell phone exactly as himself, stuck on the floor, and think he is in a gravitational system with g equals 9.8 meters per second, exactly as on the Earth. As a consequence of these two examples, Einstein stated the principle of equivalence. Physical laws must be written in such a way that there will be no possibility to detect any difference between a gravitational system and an accelerated one. Let's see the last example of Albert Einstein. Imagine we are in a spaceship which is moving with an acceleration of 9.8 meters per second, and we send a light ray from a point A to a point B with a direction perpendicular to the spaceship movement. The light ray will not reach exactly point B because while moving towards it, the point will have moved up. Therefore, the light ray will reach a point C a little lower than B. From inside the spaceship, the man will see a curved ray and not a straight line. As a consequence of equivalence principle, we state that the gravity force must be bend the light road. This is the basis of the general relativity theory of Albert Einstein. Geodetic lines are the shortest road between 2 points. A geodetic line corresponds to a light road because, as we said, it's not possible to be beyond the light speed. So, the light is the fastest way to connect 2 points. Normally, a light ray describes a straight line, but as we saw in a gravitational system, it is curved. This means that the gravitational mass curves the space. The difference between a star and a planet is on the quality of energy. A star keeps its mass away from its center as a consequence of nuclear explosions. When a star exhausts its energy, all its mass collapses and it's attracted by its own gravity. When a star has a mass bigger than 3.5 times the mass of the Sun, an incredible phenomenon occurs. The escape velocity is the minimal speed necessary to exit the orbit of a mass, and it depends on the quantity of mass and dimensions. For a black hole, the escape velocity is higher than the speed of the light. Therefore, the black hole is not visible and disappears from our universe and blows any mass that enters in its orbit. According to the equivalence principle, the black hole is equivalent to going beyond light speed. It's very difficult to accept the concept of a mass equal to 3.5 times the Sun concentrated in a point. Therefore, there exist theories that give different solutions. One theory asserts that a black hole generates a white hole and all the mass explodes in another space or universe. The theory would explain the Big Bang theory of the birth of the universe as a white hole.